Okay, so now we're going to be doing section 4.9, systems of differential equations, and a system of differential equations is really just two equations, or three or four, but we're going to probably just stick with two or three here. And we're going to solve these, again, we're just skimming the surface here of systems of equations. We're going to be solving these essentially just by the elimination method or substitution. I think chapter 8, there's a whole chapter on solving these equations using methods of linear algebra, in particular using matrices and things like eigenvalues and eigenvectors and all that. But if you've had linear algebra, by all means, you can look in chapter 8 and it might make some sense. If you haven't had linear algebra, it's kind of an uphill climb, but I think chapter 8 is maybe self-contained enough where you can do that. But I would say that the prerequisite for chapter 8 would be a course in linear algebra. In any event, we're not going to do any of that, right? We're just going to solve systems like this. So the first thing to note here is that both x and y are going to be dependent variables. The independent variable is now t, right? So when we write y prime, right, this is not dy by dx anymore. This is dy over dt. Likewise, x prime is dx over dt. Okay, so that's a big switch here. So make a note of that because, yep, if you write y prime as dy over dx, it's not what we're looking for. It's not going to come out right. All right. You also remember the d. It stands for the derivative, right? It's a differential operator. And, well, it's usually d by dx, but here it's going to be d by dt, right? And so we can rewrite the system. This is example 1 now. X prime equals 4y, and y prime equals negative 3x. Well, you can subtract the 4y from both sides, so you get x prime minus 4y equals 0. But this is also the same as x prime. We're taking the derivative of x with respect to t, right? So that's really just d of x. So this is d of x minus 4y equals 0. And likewise, for the second equation, you get y prime plus 3x equals 0. And I'll put the 3x in front. 3x plus dy equals 0. Right? So this is our system of equations, and now we want to solve it, right? So one way to do that is to multiply the first equation by d, right? So here's the first equation. Do it this way. So here's d of x minus 4y equals 0. Sorry, that's a 4. And just apply d to both sides, right? So you're taking d of the left and, oops, sorry, let's say d of 0. But the derivative of 0, of course, is still 0. Okay? And here we get d, it looks like d times d, or d squared, but it's really the second derivative of x minus, the derivative of 4y is just 4 times the derivative of y. So 4 dy equals 0. Okay? Yep. So, sorry, that's not a 0. It's not 40. It's 4 times dy. Let's see if I can fix that. Make this look like a d here. Okay. So that's the first equation. That's this. Now what about the second equation? Well, the second equation, actually, I think I'm just going to leave this alone because we have, oh, I'm sorry. Yeah, no, we do want to multiply the second equation. Well, because we want to eliminate the y here, right? We have positive dy, we have negative 4 dy. So if I multiply the second equation by 4, I get 12x plus 4 dy equals 4 times 0 is still 0. Okay, so having done that, let's look at the two equations. We have this equation, the first equation, and then 12x plus 4 dy equals 0. Well, hey, I have negative 4 dy plus 4 dy. When I add them up, I get 0 here. So what do I get? I get d squared x, or second derivative of x, plus 12x equals 0. Okay. So, yep, we've solved equations like this before. It might be more familiar if we write it as x double prime plus 12x equals 0. Right? The auxiliary equation is just m squared plus 12 equals 0. So your solutions for m are plus or minus, let's see, I times the square root of 12. So that's 2i times the square root of 3. All right. So what does that mean for x? Well, it means that x of t is going to be c1 times cosine of, I should use parentheses here, 2 square root of 3 times x, right, plus c2 times the sine of the same 2 square root of 3 times x. Okay. Oh, sorry, not x. Let me fix that. Right, and this is a function of t here. So this is 2 square root of 3 times t plus c2 times sine 2 square root of 3 times t. Yes, x, remember, is the dependency. It's easy to forget, right? Even I forgot. All right, so now that's half the answer, right? We solved for the function x. We also need to find y of t, of course. That's the other half. And to do that, now we want to essentially eliminate the x's here. So we can do that. Let me do that over here. If we multiply the first equation by negative 3, so multiply this by negative 3, we get negative 3 dx. Negative 3 times negative 4 is positive 12, so positive 12y equals negative 3 times 0 is still 0. Okay. And if we take d of the second one, right, so we're going to get positive 3 times dx plus d dy, which is, again, second derivative of y, and then the derivative of 0 is still 0, right? So now we can eliminate the x's here. This just adds up to 0. And now we get 12y plus d squared y, or reversing it, d squared y plus 12y equals 0. And if you notice, there's kind of a symmetry here. In fact, you get the exact same thing, right? Because the auxiliary or characteristic equation is still m squared plus 12 equals 0, right? So in fact, y of t here is going to be the exact same thing. Oh, sorry, I didn't mean to use red. I'll go back to blue here. So y of t is just going to be, well, we already used c1 and c2, so you might think it's going to be c3 cosine of 2 square root of 3 times t plus c4 times sine of 2 square root of 3 times t. Okay, so that looks like we have our solution, our complete solution to this system. But that's not the whole story here. We're not quite done. And the reason we're not quite done is because there's only there should only be two independent parameters here. There should only be a C1 and a C2, right? So this C3 and C4 here are not independent of X and Y, of the C1 and C2, okay? So here's how we can figure out the C3 and C4 here, right? I'm going to look back at the original equation, the first equation, the x prime equals 4y, right? So let's figure out what x prime is. So I'm going to write that up here, x prime of t. Okay, so x prime of t is going to be, well, the derivative of c1 cosine of 2 square root of 3t is going to be negative sign. So it's going to be negative, let's write the 2 square root of 3 in front, c1 times sine of 2 square root of 3t, right? And then the derivative of sine is cosine. Again, by the chain rule, you get the plus 2 square root of 3 times c2 times cosine of 2 square root of 3t. Okay? And, all right, so that's the left side. The right side, of course, is just 4 times y. So 4 times y, here's y. So 4 times y is going to be, well, I'm going to put this one first, right? This is going to be 4 times c4. Yeah, 4 times y. So 4 times c4 times the sine of 2 square root of 3t plus 4 times c3 cosine of 2 square root of 3t, right? So so this is equal to the 4y from up here. And so you can see that these two things are equal, and these kind of line up pretty nicely, don't they? In the sense that, right, these have to be equal, and these have to be equal. Okay? So, right, so your C4, 4 times C4, has to equal negative 2 square root of 3 times C1. And if you divide by 4, right, you get that C4 is really just negative square root of 3 over 2 times C1. Likewise, 4C3 is equal to 2 square root of 3 C2. So now when you divide by 4, you get that C3 is equal to square root of 3 over, sorry, that's a 4, so square root of 3 over 2 C2. Okay, so now plugging those in here, we can actually rewrite y of t. Right, y of t is now going to be C3, which is the square root of 3 over 2 times C2 cosine of 2 square root of 3t plus C4, which is minus square root of 3 over 2 times C1 times the sine, the sine of 2 square root of 3t. Okay. And so, so you should always be able to do this, right? You should always be able to take one of these equations. Obviously, we could have used this one here too, and we would have gotten the same answer eventually. But I picked the first one just out of convenience. And so, yeah, so in the end, we still only have C1 and C2. So, so you should only have 2 independent parameters, C1 and C2. The other thing I want to note about the solution here, and again, I wish I didn't write this in the first place, so consider this as your x, and this is your y here. So if you had multivariable with me, you might remember these as sort of parametric equations, right? And when you consider t as your parameter, consider it as time, you can actually graph the solutions of these. Now, it depends on C1 and C2, but given a particular C1 and C2, I'm going to do my best here. I know this is awful. So, right, so this will be the x-axis, this will be the y-axis, and the idea is when you trace these out, right, you get ellipses. So depending on C1 and C2, you might get an ellipse that looks like this. Right. If you change C1 and C2, you might get a different ellipse, one that looks like this. Right, I know, very sloppy, but it's my pen. So pretend these are ellipses, right? And so I'm trying to figure out whether these go counterclockwise or clockwise. If you start at t equals 0, you get C1, so x is C1. And when t is, say, pi over 2, or when this combination is pi over 2, you're up here. So I think you're going counterclockwise here. Right. So these sort of concentric ellipses here, these form what's called the phase portrait. And if you remember way back at the beginning, we drew the phase line. So when you have a system of 2 equations, you have x and y, your phase portrait is actually 2-dimensional now. So this is a 2-dimensional phase portrait. Okay. And again, they probably get more detailed more detailed in Chapter 8 when they solve this more systematically than we're going to do it here. But so this is the idea of systems of linear differential equations. In most cases, we're not going to ask for the phase portrait. We're just going to ask for the solution this way. And don't forget, don't leave it with C3 and C4, right? Do this step here to solve for the C1 and C3 and C4 in terms of C1 and C2. So I hope that helps. So that should be section 4.9.